Okay, so 2.5. This is our first video notes for Precalc 2017. And we are going to start off with piecewise defined functions. So vocab, what is a piecewise defined function? Is one which is defined not by a single equation, but two or more. And each equation is valid for some interval. It's basically where a graph starts, stops, and then picks up a different function and keeps going from there. The best way to graph piecewise functions, if you are good at just graphing regular functions, then just go ahead and you can look at it and figure out, for example, this guy right here is a linear equation, but it's only valid for intervals that are less than 3. So the best way to graph this first one, you can make a table if you want. Now we need 3 even though it will not be included, but there will be an open circle at 3. So 3 needs to be included. And then a couple numbers before 3 because x is going to be less than 3. So if x is less than 3, then I'm going to graph 3, 2, 1, and 0. You don't need that many numbers, but let's just do a few. So if I plugged in 3 to this, 3 minus 2 is 1, 2 minus 2 is 0, 1 minus 2 is negative 1, 0 minus 2 is negative 2. So I'm going to graph, so right now I'm focusing on this one right here. Of course at 3, 1, 1, 2, 3, 1, it's going to be an open circle. And then at 2, we are at 0. At 1, we are at negative 1. And at 0, we are at 2. So there's my graph. Okay? Where x is less than 3. So this function is not going to pick up after 3. Now the next graph is going to be 5 minus x, but here x is going to be greater than or equal to 3. So I'm going to start at 3 again, because my graph is going to start at 3, and it's going to be a closed circle. And then I'm going to plug in some numbers after, so 3, 4, and 5. I can do more if I want or not. And now let's plug them into this. So 5 minus 3 is 2, 4 minus 3 is 1. 5 minus 3 is 2, 5 minus 4 is 1, 5 minus 5 is 0. So if I graph this, at 3 we're going to have a closed circle at 2, at 4 we're going to be at 1, and at 5 we are at 0. And there is my graph. And it's going to go off the graph. And there's my piecewise function, my two pieces. Okay, one of the pieces is a linear equation for all x is less than 3, 3 being not included. And then my second piece is this linear equation for all x is greater than 3, where 3 is included. Okay, so for each piecewise function, define graph and then find f of negative 5. So let's find those. So for f of negative 5, which piece takes care of negative 5? It's going to be x minus 2, because our negative 5 is over here. So the black line has nothing to do with negative 5. So we basically plug in f of negative 5 into the top piece. So it's negative 5 minus 2, that's negative 7. Alright, for b, it's f of negative 1. So we are still using this function, because this line right here is 3 and above. So f of negative 1, we're going to use that top piece, and that's going to be negative 1 minus 2, which is negative 3. For c, it's asking for f of 0, and again, we're still in this top one, so 0 minus 2 equals negative 2. And then d is f of 3. So for f of 3, we're not going to use this top one because here 3 is not included, but 3 is included in that second piece, so it's going to be 5 minus 3, which is 2. Okay, now this is a 3-part function. So let's graph our 3 parts. And again, I mean, if you're pretty good at this, then you should know how to graph this without a table. But if you need the table, it's fine. So let's first, we're going to do this one right here. And that's a linear function. Our x is going to start at -3, and then we're going to graph only numbers that are less than -3. And -3 is not going to be included. So we're less than -3, we got -4 and maybe -5. And it's linear, so it's going to continue on. You can put more lines if you wanted to. So at -3, it's going to be 6. At -4, we're going to be at 8. At -5, we're going to be at 10. So it looks like I may have to go up by 2's. And you guys can probably do a better graph than I can over here. But let's do each of these by 2's. And even these. Let's do these by 2's. So at -3, we are right there. And we're going to 6. So 2, 4, 6. Oops, sorry. That should have been an open circle. At -4, we are going to be at 8. And at -5, which is right there, we're going to be at 10. So there's the first part of my graph. Okay, the second part is going to be between -3 and 2. So I'm going to pick some numbers, and -3 is included. And I'm going to pick some numbers in between -3 and 2. I definitely want -3 on there, and I definitely want 2 on there. And I'm just going to pick 2 numbers in between. I know it's linear, so I don't need crazy numbers. Alright, so if you plug in -3, 3 times -3 is -9, minus 1 is -10. 3 times -1 is -3, minus 1 is -4. 3 times 0 is 0, minus 1 is 1. And 3 times 2 is 6, minus 1 is 5. So basically this graph, if we at -3, which is right here, we're going to be up here at, at -3 we're going to be down here at 10. And it's going to be included, so it's a closed circle. And then at -1, we're going to be at -4. At 0, we're going to be at -1. And at 2, we're going to be at 5. And it's also going to be included. So that's the second piece of my function. And now the last one, I'm going to also do this in red over here. It's going to be x is greater than 2. We have to include 2. That's going to be an open circle. And it is linear, so I'm just going to pick 2, 4, and 6. So at 2, it's going to be -8. At 4, it's going to be -16. At 6, it's going to be -24, which I'm probably not going to be able to graph those, but here we go. At 2, we're going to be at -8, and it's going to be an open circle. And then at 4, we're going to be all the way at -16, so this line kind of does one of these. And there's my piecewise function. And again, you guys are going to have to do f of -5, f of -1, f of 0, f of 3. So for f of -5, which function are we going to use? This guy right here. So it's -2 times -5, which is 10. For f of -1, we're not going to use this one. We're going to use here, because -1 is in between -3 and 2. So it's going to be 3 times -1 minus 1, which is -3, -4. For f of 0, which function are we going to use? This one. So it's 3 times negative 1 minus 1. Oops, sorry. 3 times 0 minus 1, which is negative 1. And then for the last one, f of 3, we're going to use the last guy, which gives us negative 12. Okay, the last part right here says, write a formula for the piecewise defined function of the graph. So you see two parts here. This right here looks like what kind of line? This is obviously linear, and more specifically, it's a constant function. Okay? And then what kind of function is this? You guys should kind of be able to spot this, that this is a radical function. And let's see if it's the parent function y equals square root of x. So at square root of 0 it's 0, square root of 1 is 1, and then square root of 4 is 2. So this looks like it is the radical function. So to write a piecewise function, it's f of x equals the big brackets. You always start with like you're reading English, right? From negative infinity on. And this graph is from 0 on, and this one is from negative infinity all the way to 0. And then what is this function? Y equals what? Can we all agree that it's negative 3 because it's constant? So I have a function of negative 3, y equals negative 3, for all values x that are less than what? Where does this thing stop, is 0. And at 0 it's an open circle, so it's not less than or equal to, it's just going to be less than. And then the second part is going to be a radical, and it's basically y equals square root of x for all values x that are greater than. So my graph is all of this, greater than 0, and it includes 0 because you have a closed circle at 0. And that's it. So we're not going to make this part crazy. It's going to be simple functions that you already know. You're probably not going to see any vertical compressions or stretches. It's mostly going to be parent functions that could possibly be moved left or right. That's as hard as it's going to get. Alright, so on top of this little 13-minute video, I want you guys to work on the homework for this section. So tomorrow we should be able to get 2.5 kind of out of the way and get started on the last section, which is 2.6, operations and compositions. Alright, enjoy the first video. See you tomorrow.